be? Right, most likely to gain electrons. So most metallic likely to lose. Non-metallic is going to be likely to gain electrons. So who on the periodic table is the most metallic element? So who's the most non-metallic? Sorry, I thought I said non-metallic. Who's the most non-metallic? But you should have the periodic table out for yourself. All right, so look at helium, guys. I hear some people saying helium, which is a good choice for now, but let's think about the logic on that. Why in the world, why would an element want to gain electrons? Because it wants a full octet, remember? So it needs to have 8 valence electrons. VE is valence electrons, okay? It needs 8 valence electrons in its valence shell. Now, that is called octet, but we know that there's always exceptions to all the rules, right? So helium and hydrogen, they're teeny tiny. They cannot even accommodate octet, because how many electrons does helium have? How many? Look at helium. How many does it have? 2. And so actually those little tiny ones like helium, hydrogen, and lithium, which is pretty small, beryllium, they actually get the duet rule. What does duet sound like? 2. They get 2 valence electrons. All right, so thinking about that, is helium happy, or does it need more electrons? Happy, yay or nay? It's good. It's got 2 valence electrons. It's as full as it can get. Like, it just cannot accommodate anymore. Okay, so knowing that, who is the most non-metallic element on the periodic table?
Fluorine.
Fluorine is. Okay. Fluorine, 1, comparatively, and this is what you learned in your notes last night. 1 is fluorine big or small? Generally. So think of where fluorine is. You know, on the periodic table. There's my little periodic table there. Okay. So it's way over here. Is it big or small? Really small. Okay. So if this guy is small, my board is so off. I'm gonna have to like totally get a new board, guys. Okay. So if it's small, how many how many energy levels does it have? So I heard 1, but 1 be like 1s2 and we're stopping, right? So fluorine's got 1s2, so 1s2, 2s2, 2p5, right? So it's got 1 energy level, which is that 1, and it's got 2, which is that second energy level. So we got 1, 2 energy levels, which I'm drawing kind of like the Bohr model here. If I have 1, 2, which are my 2 electrons in the inner energy level, and I've got how many on the outside? 7. So 1, 2, 3, 4, 5, 6, 7. Okay, so I got 7 electrons there. How many more electrons does it need to get octet? 1 more, and that's where we have 1 lonely electron out here coming in. But fluorine is very, very eager to get that, so that's why we call it most non-metallic, because it's most likely to gain that 1 electron. The reason that this one is the most eager to get it is because how far away is the nucleus? How far away is the nucleus from the outside? It's not very far. It's got 1 energy level there, not a whole lot of shielding, so it's like super, super attracted to whatever's out here, which is this next electron coming in. So that's why fluorine is super, super electronegative, right? Wants electrons. That's why it also has a really, really high ionization energy, because it's going to take a ton of energy for you to rip that electron off, because it's fighting for it. It wants it, because if not, you're totally taken away from octet. We also know it's small, so its atomic radius does play into this, because it being so small means that it affects these 2 other properties. And I won't talk about electron affinity as much right now. Okay, so that kind of wraps up some of that. Darcy. They are all non-metallic. However, I'm glad you said that. So fluorine has 2 energy levels, right? But like, let's look at iodine. Count down. How many energy levels does iodine have? Look at iodine. So it goes all the way down to 5. 1, 2, 3, 4, 5. Yeah. So we got all of this shielding in the way, right? All these energy levels. And if I have 7, which I do, 7 valence electrons, 1, 2, 3, 4, 5, 6, 7. And you're talking about, oh, does iodine want 1 more? Well, yeah, it does. It wants octet. But how strongly does it want it? Not as badly as fluorine does, mainly because the attractant component, the positive nucleus, which is way in here, doesn't even know it has electrons, much less like there's ones out here where it's like, ooh, let me have one more, right? Because it's so far away from the outside, the attraction tends to diminish because of the shielding effect. So that's why it's a little different, because of the size difference. Yeah.
So why wouldn't neon be the most non-metallic, because that's farther?
Because it's already perfect in all ways. It can't take on any more electrons.
Are metallic?
Noble gases are non-metals, right? So the whole like label of metal and non-metal means I'm a metal, I have properties like conductive, malleable, ductile. Non-metals mean like I'm a gas, generally at room temperature, volatile, all those properties. But to be non-metallic means that you desire electrons. And that's why the noble gases are kind of kicked out of that group, because they're already perfect. They don't need anything else. This is a good way to describe metallic and non-metallic, metal and non-metal. Yeah.
So the halogens are going to be the ones that need to gain that one electron?
Yep. And so most of the, I mean, every single halogen has 7 valence electrons. So they all want one more. It's just some of them want it more than the others because of the whole size difference, which creates that difference in attraction. Questions? These are good questions, so keep them coming. Yeah.
I think you explained like electronegativity as wanting electrons, and then you said that non-metallic desires electrons. So what's the difference?
So some of them want it or desire it more strongly. And so it's not only, so electronegativity is not just, oh, I want an electron. It's also related in terms of like, if I have to share an electron with you, Lindsay, I have to share. Either I can share equally, you're like, you'll take it a day, I'll take it a day. You'll take it a day, I'll take it a day. Or you can have it 5 days of the week and I'll have 2 days of the week. It's about like the differences in strengths between it. Because sometimes we have to share electrons. And that's what a covalent bond is, right? They share electrons. Sometimes we have to share, but one of them takes it more often than the other. So one of them overshares while the other one undershares. So it's more about the bonding situation, which is our next unit. So we're getting into that soon. All right, let me come back here, actually, to the problem set. Let me go ahead and take a couple extra questions, and then we're going to move from here. So how about the chart? Yeah, Julie.
How does ionization energy and electron affinity apply for noble gases since they already have?
So generally, ionization energy does. Because the ionization energy, so the energy to ionize something, it's just like, if Robbie has 8 electrons, and I want one of his electrons, he's going to put up a fight. Because he's already perfect, right? He's already got octet. So he's going to really, really, really make me work to get that electron. So that means the ionization energy goes really high. So yes, it does apply to noble gases generally. And then what was the other one? Electron affinity is like how much they desire. Like it's related to electron affinity, and it does. But electron affinity is the weirdest trend. And even in AP, we go over it a little bit to talk about the exceptions, and then we kind of step away because it's more complex than any of the other ones. It has like a big wiggle room, a big wiggly trend, and that's what you guys experience when you're looking at your data the other day. So it does apply. I'll let you guys apply right now, because let's just kind of get the 95%, and then we're good. Question over here. 1C, right down here. Okay. So according to the elements, blah blah blah, how many would be conductive, liquid, or gassing, form color compounds? Okay, guys. Here's I think you guys can tell me some of these. Looking at the periodic table, which ones do you know that are colorful? Shout them out. Gold is gold, right? What else? Copper is. Anybody know what color copper is? Copper is a blue color. Okay, so actually copper and ion is a blue color, and copper itself is like a copper color, right? Kind of like a bronzy copper. So those are colorful. Keep looking. I heard cobalt. Cobalt has like a blue and pink color in ion formation. What else? Iodine is it's in solid form has a color, and when its gas form has color, but its liquid form does not really have a color. It's weird. Yeah. Mercury is silvery. A lot of metals are silvery. So what I heard a lot though of are the transition metals. Those blue ones up there that we have in like that blue color, shading color, those are all the transition metals. So looking up here, which ones are transition metals? Calcium? No. Hydrogen? No. Cobalt? Yes. Okay, that's one. Aluminum? No, it is not in the transition metal group. No. That's one people always want to put in transition metal group. Silicon? No. Sulfur? No. Chlorine? No. So how many? One color compound meaning one, that's a transition metal. Okay, so that's 1C. Another one, guys?
How do you show how to do 2C? Have 7 rounds?
Has 2C's, that you said? Has 7 valence electrons in the 5s and p. So the way you have to do it is cumulative. Okay, so look at 5s over here with me. Where is it at? Who does it start with? Rubidium and strontium. Okay, so that's 5s2, right?
Yeah.
That's to strontium. Skip, 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 skip. Then we got 5p. 5 is iodine, right? So 2 plus 5 is 7. So 7 valence electrons in 5s and 5p cumulatively will be iodine.
So you just skip the whole entire P section.
D, because it doesn't mention it here. The only reason is because it doesn't mention it. Question.
2H9.
2H, is that what you said?
Yeah.
Most reactive halogen. Okay, so again, halogens are nonmetals, right? So that's me saying most reactive halogen, which is the same thing as me saying most nonmetallic, because most nonmetallic means it wants to gain electrons. So if you're reactive, generally it's because somebody's getting electrons, guys. That's all reactive means. Either you're getting them or you're giving them. So this one's going to be, which one's the most nonmetallic in the halogen group? Fluorine. Right. All right, I'm going to hold off on problem set 6 questions for a little longer right now. Here's what we're going to do next. You guys haven't practiced electron configurations with me in a while, so going to practice now. This is called electron configuration bingo. So we're going to do this for a little while. You guys have a periodic table out? You guys going to read the instructions here? There are plenty. Please pass back all these, a number of those. Please pass back a number of these. That may not be actually here. One second. All right, you guys have about 5 minutes to follow the instructions and write down as many electron configurations as you can. The instructions are on both sides.
You just have to write
There is no free space on this side. You sure can use a shortcut. If I don't say otherwise, by golly, use that shortcut.
No, fill in the box with either the symbol that shows an element or the electron.
So it says do not write both, right? It says write either the symbol or the electron configuration. So I'm going to call out symbols and electron configuration. And if you have the symbol and I set the electron configuration for it, then you say check. If I call the electron configuration, you the symbol for it, and you say check.
Can you, if you like call that, symbol, you have the symbol from the electron, or symbol, if you have
So mix them up, do symbols and elements, because symbols and electron configurations, because I'm going to call them out both. Are there extras floating around? I handed out a ton.
Done. I got 2 people.
Actually, I'm gonna kind of help us also start something else while some people are finishing.
You should take your measure laptop. I heard the person that red laptop and make yourself like that. I'll hold the middle finger there for laptop. Or you can log on to the computer from yourself. You guys go ahead and log on. You know they say sometimes a little while before you do. Give me a thumbs up if your bingo card is complete. Okay, okay.
If your bingo card is complete, I'm gonna let you read this for a moment. It's almost exactly the same thing, it's just a different type. You can find that on my website. And then you're at your documents. Alright, love you guys and stuff, but I'm doing 1 more minute. Yeah, 1 more minute right now, and if I need to wait to play bingo, we can wait, but, just wanna try to keep us all together here. And if you have already finished, then go to Unit 2 documents, and I'll show you what you're gonna do with that shortly. Alright guys, here's what I'll do. We'll play bingo towards the end, just so I can give a couple people a chance to move on, and a couple of people who need to finish up. But go ahead and just log on to my website. Go ahead and do that now, please. And then while it's kind of coming up, I'm going to explain your, we have like a couple days of review built in here, okay? So today we're going to start reviewing a little bit more about the characteristics of the different groups on the periodic table. And then tomorrow we're going to do a whole entire day on nuclear chemistry. And a little bit more on Thursday as well. But after that, we're going to be wrapping up to include more review with isotopes specifically, and then electron configurations, which is what we're doing here today. And our test for this unit is on Monday, but Friday we have a half day. So we will be presenting our projects on Friday. So I had 25 minutes built in today for you to just start with your project groups, and about 25-ish minutes to work on this. So we're getting to that crunch time, and I want to make sure I kind of go ahead and show you both so that you can move respectively to what's best for you guys, as your project groups need to kind of accomplish a couple things today as well. So let me explain everything first instructions-wise, and then I'm going to set you free, okay? So one assignment that usually works really well for review is to use infographics. So if you pull up, go to my website, it's not my website, hold up, and you go to Unit 2, and you see down a little farther, it says, did I just miss it? Uh-oh, hold on. It says Group Characteristics Assignment, right there. Group Characteristics Assignment, I have 2 links here for you. So basically what you guys are going to see when you pull that up is a folder, a Google folder, full of PDFs. And it says teaching version because it has answers on it, okay? But they're really cool. So for example, when you click on the first one, it shows you the alkali metals. It tells you, oh, actually this one doesn't have answers on it, another one does. It tells you the alkali metals, it tells you kind of how they form compounds. They tell you about their valence electrons, some characteristics, and so forth. And I have a little infographic for every single group on the periodic table. When you click on the other link, it brings you up to a Google Doc. It talks about valence electrons first, which we have talked quite a bit about. And then down below, it has characteristics about each of the groups yet again. These are filled in, but this is a really low pixel image, so I did link right below that high resolution image right there, and you can, when you click that, it'll bring you to the actual high resolution image, which is from the Compound Interest Infographic website. There's a fruit light in here. So that's basically what you're going to be looking at, but there's tons of information there, right? I don't need you to glean every piece of information. I need you to give me a little bit. So that means the 5 characteristics about each of these groups. There are 12 total, so groups 1 through 8, plus the transition metals, the inner transition metals, which are actinides and lanthanides. So you can do it in 2 different ways, or if you have another way that you like better, then go for it. But you gotta let me know first. You're gonna make a multiple flat foldable that includes some 5 characteristics about each group, or you can work with a partner and you can make like a creative poster that has a really easily laid out description of each of these groups along with their 5 characteristics. Your summary statement underneath this will be related to the trends. I'll let you guys read that there. Talking about most reactive as well, so it's again pulling in some of that problem set 6 stuff to serve as a review. So, questions on this assignment right now? Do you know which option you want to do? I'll give you guys like 2 minutes if you need to get up and talk to somebody, if you need to work with somebody, poster-wise, or if you want to make a foldable. You can make that decision. Make sure you know where this is on my website, because then I'm going to tell you about your group, your project part. You guys are super chatty this morning. Does anybody need to get up and talk to a friend? Yeah. But this, I'm hoping that we can work on the rest of the week in class and get it done. It won't take you that long though, so like, I really thought you could get done in like 40 minutes, so 2 days and a couple minutes each. All right, well, you guys use that time. Great. Anybody need to look at somebody else and claim them with their eyes? Yeah. Hmm? I'm not going to describe how I want you to do foldable. It's up to you. You need 12 flaps. If you want to stick 2 of them and glue them together, that's the creativity part. That's up to you. I have the content that I need. You guys have the creative part. Yeah. This is not on the website, but that's why I'm leaving it. I'm going to leave it up here for today. So, but right now we have about 45 minutes left in class, okay? So, I'm going to leave this here, and if you're like, hey, we are so ahead on our project, we'll kind of be okay, then that's what I need you to work on. But if you need to go ahead and sit with your group for about 20 minutes right now and kind of get moving on the group component, because you should have your individual research on. You guys know what project I'm talking about? That one from like a year ago, right? This the scientist models. So go ahead and sit with them now. I'm going to put a timer on for 20 minutes, and we're going to see where we are. You have your laptops, you have everything you need. Do not waste time. Yes, Caroline.
Hold on, let me
Right now, no. I just looked up a video on my phone. Like it can be like a
You guys need to take every check. So get
Okay, so I'm gonna bring in a big sheet of cardboard. Remember all my Alamo?
Yeah, I do.
Atomic models.
Wait, was that the cruise?
So I'm throwing it all.
I think that was no, this is, oh, I remember this one. This one is me and Johnny was super hard and we like, we used to have like, so hard to see it was.
We have to make it happen. Yeah. Because don't we have to really? He like folds it and then lines it up somehow. Yeah. And then like that. So then once you have yeah.
What if we just put the information on like a table and then we yeah, do the and then like let's do a pop-up for each atom, like each different version.
Oh yeah, so I thought this should be
I thought we were gonna do like a word.
oh, what I was gonna do is like see how this is a phrase and then this is gonna pop up. This is gonna be my atom and then I was gonna promote one of that. Oh, okay. Sorry, I didn't know. Okay, so this is like my atom and then you put the words down. So we have to, what she said is, for like, on the actual project, we only have to have 4 facts, but we have to do this and some of your research and turn it into it. So that's not a fact. No, this part isn't a fact sheet. This is what we submit. And then these questions, she said, these are just questions you can think about, but they could be your 4 facts. So on the actual like project that we all put our focus on, we only have to have 4 facts. But then we have to turn in these questions. I don't even know what it was. I think that's a good Adam, right? Yeah. Surprise! Is this your hair? You want to pull it? You want me to get a stool for you? Okay, so when you put this thing on there, is this our picture or do you add a picture?
You put a picture on it. That's
So,
like the base to make
That's
it
what
pop.
So like, when the guy did it, he cut out like a skyline. He set up a skyline. So you would put your picture on here. Yeah, you can like, you can push it out. You guys just kind of like get a picture of what their model would look like. I like, yeah, but like,